Hey everybody, it's Tony from Adafruit, and I wanted to do a quick look at a piece of software for the Raspberry Pi called Pi-hole, like a black hole that sucks everything in. This is for advertisements. So when you're browsing the web and you're bombarded with advertisements and it slows everything down, Pi-hole is basically software that you run on a Raspberry Pi. It'll turn your Raspberry Pi into a little server, and it looks like my battery just died. Oh, interesting, I just touched it and now it's back. So maybe we'll have some fun with the light on this stream. I've got more dramatic lighting now this time. But anyway, so Pi-hole, it runs on the Raspberry Pi. It turns your Raspberry Pi into an ad blocker as just a server that you can run on your network. And then if you change some of your device configuration on things like your tablets, your phone, your computers, basically you have to change the DNS server to use the Raspberry Pi that's running Pi-hole as the DNS server, then it will actually automatically block advertisements before your device even gets to them. As far as your device is concerned, it has no idea that an ad blocker is running, so there's no software to install or anything like that. It's really pretty easy to use. I was really impressed with it and just trying it out a little bit earlier. So that's what I wanted to look at in this stream here is we'll look at how to run Pi-hole, how to set up an iPad real quick, to use it, and then see what it does. Does it work? Is it worth it or not? So let's just kind of dive in. Real quick, I'll jump to maybe the workbench view so that I can kind of show you what's going on here. So in the workbench view, that's just me down in the corner, obviously. And then on the workbench, I have an iPad right here, and then a Raspberry Pi. And the Pi, it's just running the Raspbian operating system right now. I haven't loaded Pi-hole or anything on it because I figured let's just run through. I'll go to a web page on the iPad before I've configured anything. We can kind of see that advertisements are going to load, and then after we do Pi-hole, we'll see how it changes and what happens. So let me connect to the iPad real quick. So I've got a little web page loaded here, and let me scooch it over so my head's not in the way. I was trying to think, like, what's a web page that has a lot of advertisements on it? And the only thing I remember is download.com from back in the day. So nothing against them, it's a great site, CNET and all that. It was just the first thing I thought of when I thought of, sites with ads, which they really aren't that annoying anymore on this web page. So maybe it's a bad example, but you can see up here, here's a big banner advertisement. Over here is a little advertisement right here. And I'm not personally against advertisements. I don't. It helps the web work, and it's how people can run a lot of sites like these that require a lot of money. But I can definitely understand why people sometimes might need to run an advertisement blocker. I realized it recently, like when I bought a really cheap low-end Windows laptop. It was like a $200 laptop that had like 2 gigabytes of memory. And man, it is just incredibly slow at browsing the web today because there are just so many little JavaScript things and so many ads that get loaded. It's horrible how much it bogs down the web. So I can totally understand why some people need to run these things. But so you can see, a site like this has some ads. And if I go to a different site, I was trying to think of another site that had ads. So let's go to maybe Engadget.com, which, hey, nothing against them, but they're definitely ads. At least the nice thing is you can kind of see, like, today pages load and then the advertisements load after it. It used to be you'd be waiting for the page to load because of the advertisements and things like that. So, that's one thing that using an ad blocker at least helps with, is it gets rid of, some of that load time for these. So, so you can see, everything's normal. My iPad's connected to my network. It's talking to my router, and it's just grabbing web pages directly with advertisements and all. So let's switch over a little bit, and we'll jump to kind of the main view here. Let me turn off the iPad here. So we'll go to the desktop, and we'll turn that on too. And so now you can see my desktop and then the Pi up in the corner over here. So this is the homepage for Pi-hole. It's pi-hole.net. And again, they've kind of modeled after like a black hole, that sucks in all light. I guess this sucks in all advertisement from the internet. And I've got to hand it to them. They've really made a nice web page here. They have a little 1-minute video that kind of walks through, here's what's going on in the project. Here's why you might want to use it. Hits all the highlights here of what it does. It's got all kinds of cool options. I haven't even played with its monitoring stuff on here. That's pretty neat. It has an API, like if you want to write some scripts that look at, how much data have you saved from ad blocking, you could do that. You can maybe like light up NeoPixels or something based on that. Have like pixels light up if you're, maybe some target for how many ads you want to block per day or something. They've got a little video walkthrough of how to install it. And the process is pretty simple. So you just want to start with the normal Raspbian OS. And by the way, I'll put links to everything I mentioned down in the description below, so you can hit those links later if you need to. But basically, just install a normal Raspbian operating system. So go to raspberrypi.org, go to the download page, follow all the steps. It walks you through, there's some software you probably need to write the SD card, load it up. And then they don't really mention it, but you want to boot Raspbian at least once, run the raspi config tool, expand your SD card, so make sure that it fills the full amount of space available, so that, if you forget to do that, you'll probably run out of space when you install some of these tools like Pi-hole. And then you just run this command at the top of the page here, so this curl command. And they kind of mention, like, there's a little bit of contention sometimes running an arbitrary. So what's happening here is the curl command is downloading a script, and we can actually look at this script. If I just hit this URL in the browser here, then this is going to download a bash script. So you can see this script right here, and it's going to run this script, and it's going to take that script and pipe it to a new bash session, which tells your Pi to run it. So you're basically trusting that whatever's in this script is not malicious. Like, it could be installing a rootkit for all you know, but at least the code's out here, and I'm going to trust it if I want. They mention you can review the code and run it locally if you want, but you're probably okay to just run this command. So let's do that. I'm connected to my Raspberry Pi with SSH right here. So I'm just going to paste in this command, and we'll let it run here. So it's going to download. And this is the other nice thing they've done. So it has a little menu system. It's going to walk you through, ask you a few questions, and then do its magic to set up Pi-hole on the Raspberry Pi. So it says, yep, it's going to transform this into a network-wide ad blocker. So that's cool. It mentions it's free but powered by donation. So probably a smart idea if you use it to donate some money. Now it mentions it's going to set up your server, so it needs a static IP address, which means the Raspberry Pi needs to be assigned an IP address, because you have to use that IP address when you configure your device. And I'll show you on the iPad how I configure that. So it's going to ask you, this is kind of neat, I'm using a Raspberry Pi 3, so it figured out that it's got the wireless LAN and the Ethernet connection. I'm just connected over Ethernet because it's simple and it's easy and it works, which I highly recommend, especially for an ad blocker like this. It's something where all of your devices on your network are going to be accessing your Raspberry Pi every time you browse the web. They're going to be doing their DNS lookups through your Raspberry Pi. So you're going to want that to be connected as quickly and as well as you can to your network. I mean, it could work on Wi-Fi, but it's going to be slower, maybe flaky. So, I recommend use your Ethernet port here. And then, okay, so yep, we'll pick that, say okay. Protocol, I'm going to do IPv4, IPv6 is kind of the new one, which eventually we're all going to have to switch to. Okay, so now so basically it figured out the IP address my Raspberry Pi has, 192.168.1.234, and it's asking, do I want to set that as my static IP address? Now I'm going to say no, because it got that IP address from my router using DHCP, which means my router assigned an IP address. And my router has a special range of IP addresses. I think it's like 192.168.1.200 through 255 or something like that, where only IPs within that range are assigned randomly with the DHCP. So I don't want my static IP to fall within that range, because maybe my router gets confused and gives that IP to some other device, which bad things can happen with. So I'm going to say no, and I'm going to go in and change this. So now I need to pick a new IP address, and I'm going to use 192.168.1.42. You need to pick an address that's not being used on your network. So usually something in the low range like this probably isn't in use. Go to your router's configuration page, and it should have a list of all the devices on your network and their IP addresses, and that's probably an easy way to see what you could use. So I'm going to say okay, and you want that /24. I forget exactly. I think that means like that whole range of IPs, or I'm not a network guy, so I'm just I'm just changing the number that I know. The gateway, I'm going to keep the same. This is usually your router IP address, and yeah, I'm going to say that's okay. Then it's asking, and oh, this is funny. It's kind of clipped out the question here. Let me increase the size of this. Maybe, I guess maybe we won't see it here. So it's asking, what do you want your upstream DNS to be? Because basically the way this works, your Raspberry Pi is going to be a DNS server that all of your devices will use. And DNS is the protocol that takes a name like google.com and looks up to see what's the IP address for the google.com servers. And so without that IP address, your computer can't talk to those machines. So DNS is a pretty critical service. And the way the ad blocking works is they have a bunch of rules where they say, okay, this domain or this, host name is a known advertising host. So we're just going to block this. We're just going to give you an address that doesn't resolve to anything in that case. Whereas, another site like Adafruit.com hopefully is not a known ad site. And then that'll look it up and give you that normal IP address. And the place it looks it up is from an upstream DNS server. So right here, it doesn't really matter, which one you pick. Oh, wow, because I've resized this, I've kind of messed up the whole menu system here. So I'm just going to say, okay, I'm going to stick with the Google one. Like Google has a free, easy to use DNS server. It's 8.8.8.8.8. It's like 4 8s. It's super easy to remember. Or 8.8.4.4. That's another one you can use. So always good to remember that, because sometimes you'll be on a machine and it's like the network settings are all messed up and you need to know a DNS server. So just remember all 8s and you'll get Google server. So okay, I'll hit enter for okay. And so now it's going to go do its thing. It's pretty much all automated, and it's going to go and install a bunch of utilities and pre-configure them. After this point, there's nothing else that I saw that I needed to do, like as far as answering any questions, just let it run in the background. And it takes about 5 or 10 minutes to go. So while this runs, I was going to do something in the background. So later today, I'm going to take the ham radio tech license, like your basic ham radio license. So I figured I'd do a little bit of studying. So I'll go through some flashcards, hey, what the heck, we'll just do it live on the internet here. I think I'm ready for it. I took some of the practice tests. I just started cramming last night because I realized there's a test happening today. So I figured, what the heck, I'll jump on the ham radio bandwagon and get the tech license. The tech license is the basic license. It's maybe the easiest one to get. You don't have to know as much stuff. Then beyond that, there's the general license, and then the amateur extra license. And Lady Ada actually got all 3 of those in one go. And so she kind of spurred me to say, hey, if she's got a license, then I should get one too, because we could use radios to talk to each other. And then like the extra licenses, they give you a few more capabilities, but from what I understand, just the tech license is good enough to, start talking on some of the fun ham bands and, getting into it. I've never used ham radio, but I figure it's, why not get the license and start playing around with it. So that's what I wanted to do. As far as studying goes, and I'll put links in the description below, I just read through last night this no-nonsense technician class license study guide by Dan Romanchik. Hopefully I got that right. Super great guide. Took a couple hours. You just read through. It's like 40 pages or so. And it's like a cram guide. So it goes through and it tells you like, okay, remember this detail. It actually calls out, okay, for this sentence here, like here is an actual question from the exams that is directly based on, the info here. So you read through this, it helps to have a little bit of understanding of electronics. Luckily I went to school for computer science and engineering, so, all the stuff about voltage I'm pretty familiar with, and electronics things. At least in this tech license, the basic license exam, it's not too crazy. The later ones do get more advanced, where like you actually have to calculate out, different antenna designs and impedances and things, which I would not be able to do as easily with that. So, but this is, pretty straightforward. It goes through all the rules of like, what you can do when you're transmitting and like how to set up a station and all this stuff. So super useful stuff. It does kind of mention that, this is a cram guide. Like you're not going to come away as an expert here. Like you'll probably be able to pass the test after you read this, but it's more to like kind of, whet your appetite and show you like, hey, this is the domain of knowledge of ham. Learn this stuff to get the license, and then, go further and actually, if it's interesting to you, like learn how to build an antenna or, set them up or tune them and things like that. So I read through this last night, took a couple hours, and then I've been using this hamstudy.org, which Lady Ada mentioned a few times. Really nice website, so it gives you these flashcards and things, and you can study for all the different types of exams here. So let's just go through. I'm just going to do some of the flashcards for the technician license, and we'll just kind of dive into this, and I'm just going to continue as a guest here. So I had done this earlier, and I guess it's starting over because I have a different user account that I'm using for this. So, okay, what is an ARQ transmission system? Oh, this is interesting. I don't remember this. So let's see. A system used to encrypt command signals to an amateur radio satellite digital scheme whereby the receiving station detects errors and sends requests. If I remember correctly, it is a retry scheme for digital transmissions. I'm just going to read the rest of these. Special transmission for video. No, it's not that. Method of compressing. No, it's not that. I'm pretty sure it's B. Hey, correct. Got it right. All right, let's go on to the next one. What are two components of a radio wave? Ionizing? No, it's definitely not that. Voltage and current? Nope. Electric and magnetic fields. This is the answer. I remember this from physics in college, because basically you've got voltage and then you've got the magnetic field in the opposite way for your RF signals. Oh shit, I didn't mean I don't know. I meant to click D, so I knew that one. Anyways, all right. What can happen if the antenna at opposite ends of a VHF or UHF line of site radio link are not using the same polarization? So if they're not polarized, they're not going to be able to pick each other's signal up as well. Let's see. I don't think it's A. Modulation sidebands might become inverted. No, I'm pretty sure it's C. The signal is going to be weaker, so let's go for that. A, correct. All right. What is the current flow in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? So this is Ohm's law. So V equals IR. Voltage equals your current times your resistance. So 120 equals current times a resistance of 80 ohms. So I want to do 120 divided by 80, and that's going to give me my current in amps. So 12 divided by 8, that's like, oh man, I got to do math on the spot here. That would be like, sounds like 1.5. Yeah, 1.5 amps should be the answer. All right, next. What type of call sign has a single letter in both its prefix and suffix? I remember this. I missed this one a few times. This is a special event call sign. So, all right, what is meant by the term check in reference to a formal traffic message? I haven't seen this one before. Okay, check is a count number of words or word equivalents. I remember this from the study guide. There is some mention of when you're doing digital transmissions in a header, you might have like a count of the number of words so you know how many words were in the message. Check is a box in the message. It tells you, no, that's not it. Check is the value of a money attached. No, that's not it. Check is a list of stations that have relayed the message. Now, I'm pretty sure it's A. This is like basically checking, did you get the message across? It's like a checksum, but more analog, I guess. You're just counting words. So, all right, hey, correct. The other nice thing about this site, you can hit the info here, and it actually tells you like details, especially if you missed the question. So that's kind of useful. And just as a quick check, let's see how we're doing here. So it's installing a few things. So yeah, it's installing light HTTPD. This is a little web server for it. So okay, so let's go on to the next one. Okay, what is component 4? Hey, that's a battery. I remember this from electronics classes here. So, all right, that's battery. And then let's see, it's going next one. What of the following is a valid U.S. amateur radio call sign? Okay, so they start with a letter, like a K or a W. Then there's a number, and then there are letters, from what I understand. I'm pretty darn sure it's this one here. Let's do that. Hey, correct. Okay, and just because I'm not as sure on that, I want to read this. I'll start with 1 or 2 letters, followed by number, and then followed by 1 to 3 letters. Okay, hey, that's easy to remember. What is the primary advantage of single sideband over FM? Now, I remember this question a few times. I was unsure of it the first few times. So this was interesting to me. I didn't know much about this. So single sideband is a type of AM, amplitude modulation, but you're just looking at one of the sidebands, and I guess you put all your power into that sideband, and so you can get a little bit better quality here. But the interesting thing, if I remember correctly, single sideband is less bandwidth than FM radio. So it's narrower bandwidth, that's for sure. I know that's true. Less susceptible to interference? I don't think so. Because it is a small bit of bandwidth, and AM, from what I remember, can have a lot of interference. So I'm going to say just B, narrow bandwidth. Okay, cool, that's right. What is meant by voice over IP as used in amateur radio? I've seen this one before. It's basically voice over the internet. How to identify? No, that's not it. Delivering voice over the internet. Yep, using digital techniques. That's cool. We've already seen this, electric and magnetic fields. So, yep, we know that one. What type of call sign is a single letter in both its... I've seen this is the special event one. Keeps asking me this. Okay, what is component 4? So this guy right here, that is a transformer in that circuit. So, all right, next. Which of the following can be used to enter the operating frequency on a modern transceiver? The automatic frequency control, the keypad or VFO knob, the CTCSS or DTMF encoder. I'm going to say the keypad or VFO knob, because CTCSS, if I remember correctly, this is like a squelch control. I think it's something where, like, when you're talking to a digital network, it can send like an inaudible tone. I got to go back and study that because I'm not completely sure on that, but I'm pretty sure it's not this. Automatic frequency control kind of implies that you're letting it control frequency and it's not you putting it in, so pretty darn sure it's this one. Okay, yep, keypad or VFO knob. What type of transmission is indicated by the term NTSC? NTSC is television, so it's could be A normal transmission mode. No, definitely not that. A frame compression scheme. No, NTSC really isn't compression. A special mode for Earth satellite. No, pretty sure it's got to be A on this one. All right, cool, correct. What is the primary advantage of single sideband over FM? We've seen this one before, so it is narrower bandwidth. Yep. What term describes the number of times per second that an alternating current reverses direction? That would basically be frequency. It's not speed, not pulse rate. Yeah, it's got to be frequency. So, yep, correct. When is willful interference to other amateur radio stations permitted? These are interesting questions. When it's kind of like a black or white, it's this or not that. Okay, willful interference. Now, my gut says it's never correct, and I don't remember from the study guide anything calling out like, yeah, it's okay to interfere with stuff. Maybe during an emergency, but only if the station being interfered is expressing extreme... No, it's not this. They had no mention of you can't, drone out someone you don't agree with. We've all got freedom of speech. And anytime amateurs are not protected from willful... No, amateurs, everyone has to follow the same rules. Only during a contest. I'm pretty sure even during a contest you're not allowed to do it. So I'm going to say at no time can you interfere with another station. All right, correct. Hey, I got that one. Which of the following may be a cause of radio frequency interference? This is interesting. Okay, let's see. So harmonics, I don't think it's that. Although, it could be. Like if you have a strong enough signal and it's going to have harmonics at lower frequencies, that could maybe mess with things. Fundamental overload. Ooh, I don't even really know what that is. I feel like I should. Spurious emissions for sure. Like if something, fired off some radio signals in the same frequency, that could interfere. I'm gonna go with D, but ooh, part of me says this could be A. Let's see what happens. All right, it's gotta be A then. All right, so I need to study this one. There are many things that cause interference. All three of these can cause them. So fundamental overload. This is the case when the transmission signal is so strong that it overloads the receiver, which prevents proper reception. Okay, so your signal is so large, it probably just clips through and you just get junk. Harmonics, yeah, these are like lower frequency and integer multiples. I remember that stuff. And then spurious emissions. Okay, so hey, that's one that I'm going to have to remember. What electrical component stores energy in an electric field? That is a capacitor. Basically, you've got two plates and then an insulator in between them. What are the two components of a radio wave? Man, it keeps asking me this. I'm going to keep getting it right. Electric and magnetic fields. Which of the following establishes grounding requirements for an amateur radio tower or antenna? Local electric codes, FCC Part 97. So FCC Part 97, I remember this one study guide. These are basically the amateur ham radio rules. So for sure, FCC Part 97 declares them. FAA tower lighting regulations, I don't remember any mention of that. UL, no, that's not going to be something. I think it's only this one. Local electric codes, maybe, but FCC 97 for sure. What did I miss? Oh, wow. Hey. See, these are the kind of questions where it's like, you go into this and you're like, sure, I know electronics theory, I can pass this, but there are all these little rules inside of here. So it's, don't just think that you'll ace this. Okay, so because the grounding system falls under an electrical installation, it is governed by local electric codes. Most of these are based on the National Electric Code, so most things will refer you to that. Okay, so this makes sense. So, okay, your local codes kind of override some things. All right, what is the source? And I guess real quick, okay, so it looks like Pi-hole is done installing. So configure your device to use Pi-hole as it's the DNS server. Basically, this is the static IP of my Raspberry Pi. So, okay, I'll say okay, and it's going to do its little thing. It's going to restart things and say, okay, so now it's done. And I've never done this. I forgot to try this out. So it has an admin interface. Let's just see what this thing looks like. Let's copy that URL and let's jump to this. So, wow, this is cool. I didn't look at this before. This is really nice. Beautiful little page they created here. So this is cool. So it's showing me like exactly what it's done. I guess I haven't had any queries yet, so there's nothing in here. Wow, 101,000 domains that it's blocking. So this is pretty cool. Oh, wow, so you can go in and say like, if there's a certain site that you want to allow, you can add it to a whitelist here. Or if there's certain sites you don't trust, I'm assuming you throw them into the blacklist there. So that's kind of cool. Okay, so let's try it out. Let's configure my iPad to use Pi-hole. So I need to configure the DNS server on my iPad. And let me change real quick. We'll jump back to the workbench view right here. So we'll turn that off. And let's try this. Okay, there we go. So let me fire up the iPad and I'll move it over a little bit. And we'll see how we can configure this thing. So from what actually here, I'll turn off my headshot because it's just going to block things, and I'm going to move out of the way a little bit. I'm going to actually move the microphone a teeny bit so it's pointed more here. Okay, cool. So the way to do this on iOS, you need to bring up the settings. So I'm going to open that up, and then under Wi-Fi, I'm going to go to my Wi-Fi network here, and you have to hit this little I for information. So this is showing all of my configuration, which my router has given my iPad. And the big thing here is the DNS server. So it's actually using 192.168.1.1, which is the IP address of my router. Now I need to change this to use the IP address of my Raspberry Pi right here that's running Pi-hole. And from what I saw, I can actually just go in and just type in the IP address here. So 192.168.1.42. So this is what Pi-hole told me to use. And then I think I just hide the keyboard, and I remember I just kind of, I wanted to make sure that it took the settings. So I actually clicked the renew lease. So this is going to go get a new IP address from my router. And luckily it seems like in iOS it saves my custom DNS inside of here. But just to be sure, I'm just going to close out of the settings, maybe open them back up, and then let's go back to the info here. And okay, so it's not showing anything here, but I think it's going to get that as soon as I access a web page. But it is showing my DNS server as my Raspberry Pi. So now the big test, if I go back to Safari, let me load this back up. Okay, so there's Engadget again, and this is just loaded from the cache. Let's click reload, and let's see what happens on this web page. So we're reloading, and I don't see an ad up here. It does say add choices. Let's go back to download.com, just because I remember that was another one that had some ads on there. So, okay, this is looking good. So I don't see that. Remember that ad that loaded at the top, and there was another one on the side here? So that's cool. I think it's working. I mean, it really is as easy as that. Any device I have, I can just change the DNS server to use the IP address of my Raspberry Pi here, and boom, suddenly all the ads are blocked, and you can browse the web, and it's a lot faster for this. So this is kind of cool. Like if I had my phones or like cheap laptops or things that I wanted to configure, and it's a pain sometimes to install these ad blockers, like especially some of the browser extensions. So it's awesome to block it just at the server level with a little Raspberry Pi here, so your devices don't even know or care that they have an ad blocker installed. So let's jump back to the main desktop view real quick, and let's just see if now if I look at the Pi-hole admin webpage, if this is going to hopefully give me some stats. So let's go back to this web page here, and we'll hit that. And okay, hey, now we're seeing some stuff here. So wow, interesting. So just from hitting those two web pages, it blocked 35 ads. There were 194 DNS queries. So that's like looking up a domain name. So just from those two web pages, like that's how much stuff a web page gets. There are hundreds and tens of requests that it's making. It's not just hitting download.com. It's hitting all this JavaScript and all these CDN sites and all these advertising network sites. So all of that stuff adds up quite a bit. This is kind of interesting. So it's showing, here are the sites that it blocked. These are probably just well-known advertisement sites. These are the domains that it hit, that kind of stuff. So that's pretty cool. I've got to hand it to Pi-hole. Like, they've put this into a very slick package. As you saw, pretty easy to use. Like, it's only been streaming for 30 minutes, and I did the whole install during that time. So I think this is worth checking out. A very easy way to turn a Raspberry Pi into a whole network ad blocker. And it looks like it's great and easy to use. So, even if you're new to Raspberry Pi stuff, this could totally be worth checking out. So I think that's all that I wanted to do. Oh, someone was asking about YouTube. Does it block YouTube stuff? So I don't know. Let's try that. I'll go on my iPad here. And let's see, let me load up YouTube and see if on like the Adafruit channel, if I can play something, and if we get any ads here. So I'll go here, And let's see, because I don't want to play someone else's channel, so let me find what's the last stream that we did. Come on here. Oh, let me just search for Adafruit. Okay, Adafruit. And it's loading. Okay, so here is our YouTube channel. And let me go in and let's just do, hey, how about the SQLite sensor storage? So I'm going to hit this. Okay, jumped right in. I didn't see an ad there, which I'm pretty sure, like, our channel's monetized and all that. If you're on YouTube, you pretty much have to be. And it just jumped right into playing. So normally I would see an ad there before that. So it looks like it blocks YouTube. I would be shocked if it doesn't. Oh, and wow, look at this. Did that actually update in real time? That's pretty cool. Wow. Are they using like WebSockets to push out, real-time stats? Let's go back to another thing. Let's see. Hey, let's try Ultimate GPS. Let's try that and see. Do I get any more ad blocks? Who knows? Tough to tell, but that was definitely like 35 before, so that's cool if that updated in real time. Again, I'm super impressed with Pi-hole. Looks like something worth checking out here. So if folks have questions, throw them in the chat. Let's see, I'll jump back to the main view real quick. But yeah, I don't see a lot of questions. Quick stream today. Like I said, later today, I'm hopefully going to take the ham radio tech license test. So just get the basic tech license. And I think I'm ready. As you saw, maybe got a few questions wrong, but do a little bit more cramming. I think I'll be able to get the license there. So cool. So I think I'll wrap up the stream then. So this was a quick look at Pi-hole, pi-hole.net. It's ad blocking server software, very, very easy to use and install on the Raspberry Pi. And it works as a server, so you point all your devices at the Raspberry Pi, and suddenly they stop getting advertisements because it blocks the DNS lookups for all those ads. So it looks like it works great. It looks like it even works for YouTube and stuff like that, so worth checking it out. And again, you got to make your own judgment call. Like, if you want to turn off ads, I can definitely understand when you've got like lower power devices. It's pretty hard to browse the internet these days with all the advertisements that are loaded on there. But again, hey, advertisement also helps the web work. That's how people pay for their sites. So, I can see both sides of the coin there. But anyways, so yeah, I'll wrap it up. So check out youtube.com/Adafruit, subscribe. You can see this video, all kinds of other fun videos and projects that we have. Twitch.tv/Adafruit, check that out. You can watch me stream this live and all kinds of other live streams that we do throughout the week on YouTube, on Facebook, on Twitch. I just heard that Tumblr has a new live video thing coming soon. So hey, we'll probably be on that in the near future. I like to do a couple streams every week. So on Mondays, I do what I call a quick look at different Raspberry Pi software like Pi-hole here. Last week, I looked at Visual Studio Code, which is a nice little open source editor from Microsoft. Looked at how to use that with the Raspberry Pi. And then Fridays, I like to do more in-depth, kind of detailed programming streams. So I've been doing a series on using SQLite to store sensor readings on a Raspberry Pi with Python code. And I've done 3 parts on that so far. And so this week I'll do a 4th part. I think it'll probably be the last one in that series, and maybe look at using different database engines and things in that one. So check that out. And then maybe during the week I might do like a Circuit Playground stream or something, add some more fun examples to it. So tune in, check out all the fun stuff that we do, and then subscribe, like, comment, let us know that you're getting value out of these videos, that you like what you see, and that'll keep us going. It kind of keeps us, lets us know that people like this, and that we'll keep doing it. So that's it. So this is Tony from Adafruit, and I will see you guys on Friday this week, if not earlier. So until then, take it easy.